Hey everybody, another video that obviously I wasn't planning to make because I've already started doing something, but I had picked up this EMP-30 from a friend of mine, and it was looked like it was just sitting outside in a barn, super filthy. I tried to clean it up the best I could. I might still try to clean it up a little bit more, I don't know, I doubt it, but anyway, these are pretty cool. I've done a video on it, but I haven't disassembled one before, and because it comes in so many pieces, I thought I would go ahead and show the reassembly of it, because I'm not even sure how to put it back together at this point. I didn't take any pictures, of course, so I'm going to be guessing a little bit, and maybe comparing it to the other EMP-30 I have. And then also, somebody on Claw kind of questioned whether this can burn, an EMP-30 can burn a bipolar PROM. So that's what this video is going to be about, and I'll go ahead and start reassembling it. Alright, so I was looking around at this. I'm trying to figure out what all these are. This looks like some type of voltage. It gets multiple 7805s, some TTL chips. This board here has an FPGA, a microcontroller, some SRAM, so this is probably like the brains of the system. And then this board here is your power. Your power comes in here. You have a bridge rectifier, you know, some filter caps, and different diodes and stuff, probably generating your different DC voltages. I don't see on the board. I haven't really looked at it. You got a couple more 7805s, 2955, another pick here. It looks like maybe two different picks. I don't know enough about this stuff, but anyway, this looks like it's controlling the power, etc. And then this here has a whole bunch of read relays on it, and some 3055 MOSFETs. So it's interesting how they design this board, this EMP-30. Basically, it's got a couple standoffs here. I'm a little under the weather, so let's see, how am I gonna? It must go like this, I think. Yeah, just like that. I don't think you can put this in wrong, so. And this goes through the top, so I know this is the top part. And let's see here, there's this like little riser card here, which must go like this. Let's see here. It's gotta go like this, yeah. Interesting. I think I'm gonna have to lift this part up a little bit. Then put this board in probably like this. Okay, there we go. Yeah, it's kind of weird how I don't know if these are 80 pin or these DIMM type of things. That's how they chose to assemble these boards together. It's kind of wacky. I don't know how this is going to come out on the tape, and I'm not a little under the weather if I didn't already say that, so my voice is messed up. Like that? Okay. I think that's right. And then this board goes in like this. And then this must go in like from this side. So yeah, that wasn't as hard as I thought it was going to be, since I didn't remember exactly how it came out. But I have one screw to kind of screw this in here real quick. Alright, I got it started just a little bit, so you can see there's a standoff there. This was actually glued in when I took it out. Uh-oh. Just seems like a lot of things that could go wrong. It's kind of wacky, huh? Especially for cold solder joints, maybe. But it looks like it's okay. So let's see here. So this is the bottom, and the fan, it has to go like this. That's it. I think. Yeah, it fits in there pretty good. Actually, I think, you know, that's got metal instead of plastic. You know, it's got metal inserts here for the screws, which is nice. I just have to finagle this thing in there, maybe. Alright, I actually had to take it all the way apart again to get this to sit in there correctly. If I show, let's see if I show, I guess I could have showed it all over again, but basically it was this riser card that was not seated in correctly, so that was preventing this from going in cleanly, but it should be good now. Yeah, so if you're ever reassembling one of these and it doesn't go back together easily, the case, then don't force it, take it back apart, look at your work. But I'll just have to put in some few screws. And I will be right back. It is missing one little rubber foot on it, but let's see here, the dip 48. This thing still looks like kind of dirty. I don't know. I can't get it off. It's like discolored or something. It's weird because it was just sitting on the top. If you, oh, you know what? This is missing the little clasps that hold it down too. I took a picture. Hopefully, you don't need it. It's holding it in, but I think there should be some metal clasps there. If you see, for your socket there, and then we'll just put in 301 like this. Oh, it's bent a little bit. That's what it is. There's this little piece of plastic there is maybe broke a little bit or something. Not completely broke, but it's definitely was in the way. There we go. Alright, now we're ready to power it on. I have it, a 12 volt power supply plugged into it. I actually, it's, I think, I can't remember, this is a 4 amp, 12 volt DC power supply, but you can use, I think, 15, you can use either AC or DC, like 15 volts AC, but a standard 12 volt DC power supply would work as well. And I also have a parallel port connected, and this thing will not turn on, even though I have the power turned on. It won't turn on until the software turns it on. So hopefully it's dry enough, because I washed all the boards and put them on the fan. Get our Needham EMP-30 software. Says it's trying to communicate. Let me make sure. Do I have this actually powered on? No, I actually don't have it powered on. Helps if I plug the thing in, as you can see there. So let me plug that in. Alright, now it's got power. I hear the fan on. It's missing an LED for the power button, but it says it's good. This device requires socket module. What the heck? Okay. I don't know what's going on there. Let me power this off. That's weird. Maybe because the last device that I had in there needed the 303 in there. Kind of wacky, huh? All I had to do is hit cancel, actually. So let's hit device. Oh, dang it. I know why. The power LED, I'm going to have to take this back apart. The power LED is bent down instead of being bent straight up. That's why, I think. Let's do a Intel. I have a chip right here. What is that? A 2516 TMS. Texas Instrument. There. Alright, it says I wonder if there's a way to do a self-check. I think it does a self-check anytime you power it on. I think it does a self-check, but I'm not sure. Alright, let's see if we can read this thing. Pretty sure it goes down like that. It's definitely got data in it. Cool. Alright, let me pause and see if there's something else. I took it back out of the case, and you can see that this LED, I don't know if it was like that before, or if that happened while I was cleaning it, or what, I don't know. Just want to carefully do that. Or maybe it happened when I was trying to put it back in. Why is the green one not popping through? Now the green one is a little bit closer. You can see that there. So it doesn't pop through like the red ones. There's also a red LED down here, which I don't know why they have that there. You can't see it through the case, obviously, so interesting. Alright, there we go. Alright, so I'll spare you, dang, I can't talk. I'll spare you the reassembly with the... So now we have our power LED there, so let's go ahead and restart. I actually turned on the log level of debug. So as it loads up, it makes communication with the parallel port. The power light comes on, your busy and good lights come on. And if we scroll back, looks like there's 676 messages there. It looks like basically when the program starts, it loads up all the programming algorithms for the different chips. And I scroll down, then you get to this part right here where it's loading the last algorithm that I was using, and then it says CPU result. Now it's actually making contact and communicating with the programmer itself, and it says it's reloading the FPGA, sends the FPGA information, loads that good, and then does a checksum on probably whatever was loaded into FPGA, I assume. Gives you a CPU result. I don't know what that should be, but I can cut and paste this in a notepad file and then compare this to my other EMP-30 as well. Actually, I'll do that off camera. Framework, CPU loaded good. Oh, okay, this is actually where it loads the last file that I had, saying that I need the DIP48 and family module 301, and then that's it, and it's ready to go. So I'm going to go ahead and just read a couple EPROMs and just make sure that it can read them and verify them as well. So I will do that. Alright, I put in a Paperboy ROM that I had. It's a 27256. And let me clear the log here. I know this is kind of boring, but I'm just documenting some of my testing that I'm doing to verify that this thing is working. So I loaded that device in. Just went to my Paperboy folder there and loaded in that vid N06. Open. Okay. And then I'm going to hit verify. And you can see that it's no error, verified. Okay, so I would say this thing is working. I haven't tried programming a chip, which obviously is going to use different voltages, but I will do that. But I think what I'm going to do is actually try to burn a bipolar PROM with this or my other Needham. Be right back. All right, I'm ready to try to burn some PROMs, I guess. See if I can get this. You can't really see it, but this is a Tesla 74S287, which is the equivalent of an 82S129 from Signetics, and these are MMI 6331s. Whoops, you can't really see this, but 82S123. So I have some Battlezone PROM files here. The one thing I noticed is that I can't use the Windows version of the EMP software. I have to go into DOS. Can't really see that, huh? Let's see here. Oh boy, we're in trouble. All right. There we go. Might have to crop this or something. But I'm going into the DOS software, and this could be a little bit painful here. Hopefully you can see this somewhat okay. We're going to select our device. We're going to go to, there is no Tesla in here. There is no, even MMI, I don't think it shows, only shows PAL chips. So we're going to try. I don't know if this is going to work or not because it's not the exact manufacturer. But we're going to go to Signetics. And go to 82S123. And it says to put in DIP48 module. I have that. And I have the module 300A, which is correct. I have that. If I take this off real quick, you can see I have the 300A, which is a reproduction from somebody on Clove for the DIP48, and I need to select a file. And let's see here. F1. There we go. Let's go. And we want 036. The file name is, let's see here, 36174. So that's the file name. Now we want to load that file. It says 32 bytes loaded, which is correct. We're going to put our chip in. I don't even know if you can verify these things are blank. I guess so. Yeah, you can read these. I haven't done this before, so this is my first time. These chips are not cheap, so let's see. We want to verify the device is erased. Check part number. No, that's not right. Good. I just was experimenting. I grabbed one of the 82. Let's see. Dang. This is from Pac-Man Plus. It's a 82S123 or the equivalent of it. And I grabbed my other EMP-30 thinking there could be something wrong with that. And plus, I don't know if I ever did test these reproduction family modules, but anyway, put that in there. I was getting the same error before, but if I read this device here, it reads it out okay. So I'm going to go back to what we were doing and put in my Tesla 123 chip. Alright, actually I have a only a couple of seconds here left, I guess. I have a MMI chip in there. Verify erase error. So I'm able to read all of these MMI chips I got off of eBay, but they all show that they have some data in there. So I don't think these are blank. So probably going to be a bust here. Alright, it's been a couple days, and I actually, or several days, I actually ordered some official Signetics 82S123s, and I have those. Hopefully, there we go, focus a little bit. I have that in my, take this off, my EMP-30, just like that. I also bought a different power supply for one of the ones I've just picked up. But anyway, if you can see this, we have the chip selected. We're going to verify the device is erased. Oh, we lost communication with the hopefully we can get back connected here quickly. There we go. Alright, so we're going to select our device, Signetics 82S123. And hopefully you can see this okay. Maybe right on the top part. We are going to verify the device is erased. It says verify device, verify erase successful. We're going to read the device into buffer, and we'll look at the buffer, and you can see it's all zeros. I think that's exactly how it's supposed to be. If this was an 82S129, I think you would see zeros and then 0 ones. For the ones that, anyway, it's a little more complex bipolar ROM discussion, but this is how it's supposed to look, as far as I know. So we know those other ones weren't, either they read different, or FFF is not what you should see on a bipolar PROM, as far as I know. So now what we need to do is we're going to try to program this. Let me pause and load in the Pac-Man 7F probably. Alright, I have selecting Pac-Man 7F. We're going to load that file from disk. Says it's loaded. Let's look at the buffer. Okay, we got 0007, whatever. Looks correct. And now we are going to program with selected algorithm. Let's see what happens. It says device programmed. That's pretty awesome. Let's read the device into buffer, or no, let's verify. Device verified. Read it into buffer. Press any key to continue. Buffer editor. That looks exactly the same, I think, right? 0007, and then the second line is all zeros. Load file from disk. Buffer editor. Yep. I would say it's, we just proved it. Whoops, damn. I'm excited. I'm tripping all over things. We just proved that an EMP-30 can program a bipolar PROM 82S123. So I'm going to end this video, although I do have this EMP-30 that was giving me some errors when I was going over voltage when I was doing I might do another video on trying to fix this thing, because something's not 100% with it, based off of that error we saw in the video. So alright, cheers guys. Hopefully this is comes out okay, since I paused so many times. So talk to you later.